Here's the general idea to solving systems of equations using graphs. Our first step will be to make sure our equations are in the form y equals some function of x. Our second step is to input these equations into the y equals function on the calculator and then to bring up the graph. Our third step will be using a handy little function on the calculator to solve for these intersections. If you need some review of these concepts, please go back to Module 2, Lesson 3 to go over them and just to get a general idea. Let's jump into our first example. Here's the system of equations we're given. Y equals negative x plus 5 is our first equation, and our second equation is y equals 6x minus 5. First thing, we just need to check to make sure they're in the y equals form, and they are, so we can input those into our calculator. And so my first equation will be negative x plus 5, and my second equation will be 6x minus 5. Okay? And this is what our screen should look like. Now let's take a look at our graph by pushing the graph button on the calculator. Looking at this, we can tell it intersects between 2 or 3 when x equals 2 or 3, but we can't determine for sure. Now I'm going to teach you a handy little trick. And bear with me. I want you to push the second button and then push the trace button, which is located next to the graph button on your calculator. You should have the screen pop up with across the top it says calculate, and then it says value, 0, minimum, maximum, intersect, and then some scary looking math right there. I want you to scroll down to where it says intersect, and that should be 5 with the semicolon before it. I want you to push enter. Now looking at your graph, you should have a cursor on one of your lines and it should be flashing. I want you to move that cursor using the arrow buttons, your left and right arrow buttons, close to the intersection. You don't have to be exact, but just move them close. And when you're pretty close, push enter. And after doing so, the cursor will move to the other line and it'll be flashing as well. I want you to move it again using the left or right arrow buttons close to the intersection. And you don't have to be exact. And push enter. After you push enter twice, across the bottom it should have guess followed by a question mark, and it has x equals something, y equals something. Push enter one more time. And it says intersection at the bottom, and then it gives the x and y coordinates. And we're told that the intersection occurs at the point x is equal to 1.4285714, blah, 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 blah. And the y coordinate will be 3.5714286. Okay? That's a very, 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 very cool little function the calculator can do. Okay? Let's work on another example. The system of equations is y equals x squared minus 5x minus 9. And our linear function is y equals 1/2 x minus 5. Now notice one equation is a quadratic, and since both are in y equals form, we can input these into our calculator without any algebra. And my first equation will be the quadratic, so it's going to be x squared minus 5x minus 9. And my second equation will be the linear function, and it's 1/2, so it needs to be parentheses 1 divided by 2, close parentheses, x minus 5. And this is what your screen should look like after inputting those functions. Now let's go look at the graph. And while the calculator thinks, it pops up, and we see that there are 2 points of intersection. Okay? We're going to use that little function that the calculator's got to figure out where these are. So again, we will push second trace. We'll have the calculate screen pop up with all those functions that are on there. We're going to scroll down to where it says intersect, push enter. I'm going to deal with the intersection that's on the left, the one that's to the left of the y-axis. And I want to move the cursor close to that intersection. And it's important that you're close, because what will happen is it may actually calculate the other intersection. So let's move close. You don't have to be exact, but move pretty close. Push enter. And after pushing enter, the cursor will jump to the other equation. Move that close to the point of intersection. Push enter again. You'll have your guess question mark pop up at the bottom of the screen. Push enter one more time. And we find that the point of intersection for the for the point of intersection on the left is the coordinate point x equals negative 0.650 something something something, and that the y is equal to negative 5.3252. Okay? That's the first point of intersection. Now we need to find the other intersection. Again, we're going to use the calculator command. We're going to push second trace. We're going to go down to where it says intersect, push enter, and we need to move our cursor over to where the second intersection occurs. And sometimes you're going to have to sit here and move the cursor because it takes a little bit to move over there. And I've moved mine close to the intersection. It doesn't have to be exact, but it just needs to be close. We'll push enter. The cursor will appear on the other function. Make sure it's close to the intersection. Mine's almost on top of it. I'm going to push enter again. You'll have the guess question mark pop up on the bottom of your screen now. Push enter one more time. And we're told that the point of intersection for that intersection to the right of the y-axis is 6.1504, negative 1.9248, x equals 6.1504, y equals negative 1.9248. Okay? Now, let's do a recap on how to solve these problems. The first thing we should do is make sure that the equations are in proper form, that it's y equals some function of x. Second, look at the graph. The third will be, we're going to use the trace command that we have, so we need to push second trace. We'll scroll down to intersect, push enter, and then we'll move our cursors around accordingly close to the intersections. And then push enter, and we'll get our points of intersections. That'll wrap us up. I'll catch y'all next time.